So, hi everyone. Thank you for joining today's Remedy Discord event. And today's topic is stateful fuzzing for security with Foundry and Echidna. Oh my God. And let me introduce you to our guests. Today we have Alex, or known as Alex the Entrepreneur. He is a security researcher lead and also the co-founder of Recon. And also from our side, we have Jason. Jason is a security researcher from Hexens who works on Glider. And in his spare time, Jason also fuzzes blockchain systems and their underlying. And in today's event, Jason will be fuzzing a testing rewards manager contract with the help of Alex and their team's new Recon Extension tool in real time. So I'm very excited to see this picture. If you guys have any questions in the process, please drop them in the comments, and guys will get back when comfortable, right? I'm
Great, thank you for having me.
I'm passing the microphone to you guys.
Thanks, Alan. Hello, Alex. How are you?
Good. How are you?
Doing well. I can't complain. So today we're going to be talking about your tool that your team has been working on, Recon Extension, and also Chimera framework, which is a fuzzing framework for Solidity smart contracts. This is something I really haven't touched on much in my own research, but as I've played around with the past week, I've really enjoyed it. Can you just kind of give like a brief description of both Chimera and Recon to anybody who's not familiar with it?
Yeah, first of all, thank you for having me. And in terms of current state of the art of stateful fuzzing, I guess to start there, stateful fuzzing, in difference to stateless fuzzing, consists of testing multiple smart contract calls where all of the calls are randomized, and then we will run some sort of assertions on top of the contracts. And there's many tools that allow to do it. As of today, you can use Foundry, Chimera, Echidna, as well as Almos and Control in a more limited capacity. And that's really our goal at Recon with the Chimera framework, was to allow you to write test once with Foundry and then be able to run all of the other tools on top of those same tests, with the idea that those tools are more specialized in breaking the properties. They're just better, they're more specific, but then we can always give you a repro of a broken bug in Foundry so that you can debug it with Foundry, which is by far the best developer tool overall. And so that's what the Chimera framework did, was famously created by Antonio Vigiano, co-founder of Recon. And in terms of what we do at Recon, we do audits and security reviews that are guided by invariant testing. We also have Recon Pro, which is our cloud solution that allows us to run this type of test for a long time on specialized hardware in the cloud.
Excellent. And I think today we're going to be demoing Recon Extension and Chimera to the audience. What are we exactly going to be working on today in terms of like what are we going to be fuzzing?
Yeah, this is a contract that it's called a rewards manager. It's a contract I wrote when I was a badger. It's actually audited by QuantStamp. So it's technically audited. We never launched it for many reasons. One of them was some economic issues. And then the second reason is the gas cost that the contract has. But fundamentally, it's a many-to-many contract that allows anybody, whether a EOA, wallet, contract, etc., to register themselves as a vault and distribute points to specific addresses. And then from there, those points can be used to claim rewards, which are arbitrary, as in you can have any token set to be a reward, and you can have any address set to be a vault, meaning a distributor of those points. And there are some interesting class optimizations, namely a couple of functions called rip and tear, which are a Doom reference. But these are destructive functions that trigger gas refunds to save on gas. So the basic idea around the contract is really simple. It's just a linear points system that gives you tokens. And then once we dig deeper enough, there's probably some interesting stuff we're gonna find there. And so in terms of the goals with invariant testing, we will start by, and this is also how we structure all of our engagements. The first part will be to get to compilation, should be fairly straightforward. Then we want to get to coverage, meaning that we want to make sure that the tool reaches all possible combinations, or at least the vast majority of them. And then from there, we want to write properties. And then we're going to iterate to possibly change the type of test that we're performing, as well as improving our properties. And the Recon extension should help you achieve that goal, because it offers you the ability to scaffold the entire suite in one click. And then it gives some other tools that help you evaluate the quality of the suite and also iterate much more rapidly.
Awesome. So just to be clear, everybody could see my screen. I want to make sure I'm sharing my VS Code.
I'm seeing the Discord as of now.
Okay. So give me a second. I just need to update the settings. Okay. Let me know if you guys could see it now.
Yep. Good.
Yep.
I probably would zoom in a couple of times for the audience at home.
Sure. Maybe that's too big. But
It can be a bit uncomfortable for the developer, but it definitely should be good for the phone watchers.
sure. Is this good for you guys?
Yeah, looks good on my end.
Okay. And of course, we'll be also posting this on YouTube. So if anybody is watching on the phone, you could certainly wait for that to be released. So I have went ahead and downloaded the Recon app from the VS Code marketplace, and I have it installed. I've also went ahead and pulled your rewards manager repo from your own GitHub profile, Alex. And we'll post a link at the end of this chat where you could find this same repository. Here, I've also just deleted the test folder because I kind of want to start this from scratch. And now I've opened up Recon. What is the first thing that I should do as I'm wanting to write fuzz tests for this? I assume it would be wanting to click scaffold.
Yeah, the first thing we will do just to make sure the project is in a good spot is to forge build. We will just check that we have imported everything. The system is good by itself. And what Forge Build will do is it's going to generate the out folder. And in most projects, that's the root/out. And so the moment you do that, the extension is going to pick that up. And if you navigate to the extension on the top, you'll see a selection of contracts. Those are typically filtered by the SRC folder. If you end up not finding a contract, you can either refresh with the refresh circle arrow, and there's also an eye that allows you to possibly scaffold contracts that are in more exotic folders. For example, in a test folder or a script folder. We disable them by default, but that's the more advanced stuff. And so the goal of the scaffold section of the extension is to give you the option to choose which contracts you want to deploy and which contracts you want to generate target functions for. Target functions can be a bit unintuitive until you see it. That's why I would rather have you just press the button. There's also an option to have them separated. You can see that you have currently selected the rewards manager in a separated mode. And that simply means that we're going to create a folder called targets and a file called reward manager targets. And that's where we're going to put all of our handlers, which we're going to talk about what those are later. So now the extension looks good, compilation looks good, and you will simply click on scaffold, which will generate a bunch of our boilerplate for the Chimera framework, whose ultimate goal is to separate the target functions, which is what we use to move the story, basically, to influence the contracts, the properties, which is what we use to perform the tests, the setup, which is how we deploy our contracts, is basically the constructor. And then we have a few other files which are effectively just there for software engineering reasons. We have the before after for ghost variables. We're probably not gonna look at it today. We then have the critic tester, which is the contract that we perform all of our tools call, meaning we tell Echidna, Medusa, Halmos, etc. to call this contract. And then we have the critic to Foundry, famously invented by Antonio, which is effectively the contract that allows us to break the properties with other tools and then quickly paste them into this file for us to be able to debug any broken property with Foundry.
So one thing that I'm just trying to make sure I'm following you. What you've done is Recon Extension is going to generate this entire framework for us to fuzz against the Solidity smart contracts, which is not something like I've never seen that in typical Web 2 fuzzing. I've always seen just the standard like library that we have, but everything we had to do in other sort of environments is always just custom made. But here, what you've done is we're just relying on a framework that does a lot of the legwork for us, because I have to guess this would take probably several hours to write if you were writing everything from absolute scratch.
I will start by saying that the tools such as Echidna and Medusa, but even Foundry, they are unopinionated. They're completely unopinionated. And so the way you will fuzz on Web 2 is typically you will have a fuzzer and then some sort of a CLI that receives the output from the fuzzer, and then it gives you some output itself. And that effectively will be equivalent to us having just one function that needs to be tested. Whereas with smart contracts, you tend to have nested dependencies. And so when you're using Echidna with nested dependencies, for example, a token, then you really don't have an ergonomic way to handle those dependencies natively. Because if I tell you that you want to fuzz a Uniswap pool, then you can fuzz the Uniswap pool, but you would have to deploy those tokens before you're able to reach any meaningful state. And so we have recognized that this pattern is very common. And so that's really what we do with the extension is we have a setup file because we expect you to be forced to deploy more than one contract in order to reach the starting state that is meaningful enough for you to explore those combinations. And then we also have the opinion that you want to enumerate the target functions, meaning the functions that would help you explore the combination and help you explore the state. And so because we see that so commonly in the vast majority of projects, then we simply enforce it at the boilerplate level, which obviously is more complex than a basic fuzzer. But at the same time, for most DeFi, this is really the bare minimums before you can even start to fuzz a smart contract system.
Right. Okay. So we're here at the setup contract, and I see that we are deploying a rewards manager contract, which is the one we're targeting. The thing that I heard you say when you're talking about what the rewards manager contract is that, you know, we have users and we have assets. So my next guess would be is that we want to add users and assets to our sort of test environment, so that we can write really great property tests.
Absolutely. And this is the innovation that we more recently launched with the extension and the launch of our second version of our template. But if you check the setup, you'll see that we import a actor manager and an asset manager. And these contracts, they give abstractions that allow us to know all the meaningful ERC20 tokens that we deployed, and that's through the asset manager. And then we also have the abstraction of all possible users, by using the actor manager. And that's because of a implicit decision that comes from our template. Our template has target functions, which are public functions. And so by definition, if we call them internally in Foundry, then we are the contract performing a call. Whereas if Medusa calls it as an external function, then Medusa will be the message.sender. And so in order to reconcile that and also to keep the coding as easy to understand as possible without using low-level assembly, we simply use the actor manager, which exposes a few functions such as get actor, add actor, and get actors, which ultimately allows us to know who the current actor is. It allows us to get all of the possible actors, and it also allows us to register a new actor in case we want to either have different colors. And the culmination of this integration is done through a file which we call the manager targets. It's another part of our boilerplate. And these manager targets allows the fuzzer to choose when to switch to a specific actor. And so you can see how we want every operation that the fuzzer takes to be explicit so that when we go and debug the trace generated by Echidna, Almos, etc., those operations are going to be visible in the trace because if a smart contract attack or a bug can be found with one actor, then we don't want to see a complex trace. Whereas if we need more than one actor, then we definitely want to see that explicitly so that we can quickly understand what's going on.
Got it. Okay. So looking at these two manager contracts, both the actor manager and asset manager, I think I have enough information to add assets. I think this is going to create a new asset for us. So let's go ahead and set up and just create several assets. And I'm passing in the decimals here for that token. And we'll just do 10. Obviously, I could add more if I want to, but I think that's okay. And I also saw an actor manager. There was the add actor. So this accepts address. So I guess when I add actor, passing an address, that represents that new actor.
Exactly. And so by default and by convention, you already are this, so you don't need to add that actor. It's always added by default because that's the contract. But what we also do by convention is we consider this as the admin, meaning that our contract will have privileged permissions. In the case of this contract, they don't have them, but we will typically register some other accounts such as Bob or Alice, and we basically will now know that our fuzzer has the ability to switch to new assets, and it also has the ability to switch to new actors. And once we look at the target functions, we'll see how the actor works. And it's going to be very simple for everybody to understand. I'm seeing
So I guess maybe next
here. Yeah.
Go ahead.
I'm seeing the right move, which is that once you set up the assets and the tokens, even though this is just a few lines, you really are implying a lot of stuff. And so the best next step is really to just build and see that the code works as intended.
Yeah, I was going to ask that. It seems like Forge build is a very good way to just check the code that you're writing as you're going through it to make sure that you don't come across any sort of issues.
Yes, and this is something that I cannot oversell. It's so easy to ignore this, but the reason why Chimera is such a good framework is because if you can compile it with Foundry and you can test it with Foundry, it means that our other tools, which can take minutes to compile, will work in the same way. And so the Forge build here means that if you run Echidna, you're going to be successful at running Echidna as well, even though it's much slower than Foundry.
Okay. So I think setup is fine. We've ran Forge build. Compiler is running successfully. I guess maybe the next step in my head would be to run Scaffold just to see an initial coverage report of the rewards manager.
So at this point, we have scaffolded. So we probably will want to scroll down a bit and we will want to instead run the fuzzer. So there's another button down there. allows you to choose the fuzzer, which can be Echidna or Medusa as of the current release. And we have many modes, but typically speaking, in a common engagement, the first time we will run Echidna in exploration mode, which means that it's ignoring any possible assertion and failure, and it's simply trying to maximize the state space exploration so that it can build a big corpus, which is an advanced idea. But building that big corpus means that Echidna knows how to quickly try new combinations, and anytime we rerun it, it's going to be much more efficient at re-exploring those more complex combinations.
Got it. And that sort of makes sense to me. There's no reason for us to do assertions. We don't have assertions yet. We really want to take advantage of this exploration state as much as we can, so we set this mode to explore. Okay. So I'll go ahead and click on this button, and it looks like I don't have Echidnas installed. That is wonderful.
Yeah, so if you don't have Echidna installed, we can talk about installing it. There's basically two ways, but they both require you going to github.com/critic/Echidna. And the main option will probably be to use brew, which most Mac users use, to install Echidna through brew, which will take only a minute or so.
All right, so I did, and it seems like it's already installed, which is strange. If I just check. Okay, so it's running on my terminal, but it doesn't seem like it's running in the extension. Could be just a minor bug.
Is this the last version of the extension?
You could see. Recon. Maybe we just had to refresh it.
Yeah.
Update. Let's see what version it is.
I should be on the right, a little bit down below on the right.
Yeah, I'm just trying to 22.
Okay, 22. So yeah, it should be the last version. There used to be a .env issue that made it so you couldn't find it. I thought we fixed it, so we'll have to investigate a bit more. But we have an alternative, and the way you will run it is you go in the critic tester, and there's a command on top of the critic tester that shows you how to run Echidna. And this is really the downside of using Echidna. It's really verbose. You have to type the compilation, the name of the contract, where the config is, the format, the number of workers, and the test limit. And so by default, though, when passing that command, we will most likely be running in assertion mode, which is fine. We can run it, it's okay. But generally speaking, when we start an engagement, we will also add the --test mode to be exploration. And that's basically how our experience of Echidna is. We will see the number of target functions. You can see there's 0 out of 19. That means that there's 19 different possible functions that the fuzzer can call, and 0 of them caused a assertion failure. At this point, we have no assertions that we wrote, so this seems okay. And then you can see on the right that there's this coverage line and this corpus line. And basically, the coverage line is counting the actual lines that can be hit, whereas the corpus is the number of sequences of calls that are being stored by Echidna, meaning that Echidna is effectively creating 35 possible sequences of calls that resulted in improving the coverage from the fuzzer. That's because this fuzzer is a coverage-driven fuzzer, which means that the way it determines whether an input is good or better than what it already has is whether that that input increases the coverage on the smart contract. And so, by definition, yeah, we're basically trying a bunch of random combinations, and then we're storing the ones that improve the coverage as a means to be able to replay them in the future as well.
I have a quick question. What, we talk about the importance of coverage, but I don't think we talked about why we want to add coverage for fuzz tests. And I think if somebody who's mainly just been writing unit tests may not be super familiar with coverage in regards to fuzzing. So why are we wanting to make sure our coverage is as wide as possible?
Okay. The key consideration around fuzzing in general is that you want to perform fuzzing to try things that you wouldn't try on your own. And that's because even though we spent quite some time to make this easy, we still spent 30 minutes to get to this point. Whereas for you to write a simple test of a deposit, of a notified transfer, of a mint of a token is so much faster. However, it has the limitation that you're only testing it with one input, with one config in one way. And so that's the key difference with stateful fuzzing versus testing in general, is that stateful fuzzing is trying as many combinations as possible. It's trying to approximate all of the possible combination. Obviously, it can never try all of them. That's why it tries an approximation of them. And the way in which it assesses its ability to try all the possible combination is by getting you to cover every possible branch and every possible line of our contract. That's because once you've covered, the idea behind, which is not completely correct, but the idea behind it is that once you've covered every possible line of the smart contract, you have plausibly explored a vast majority of the combinations that the smart contract can go through.
Got it. Okay. That makes sense to me. I can't see chat right now. Is there any questions for chat while we're waiting for this to complete? If not, we could continue.
Yeah, we had a question about Echidna and Medusa. I answered, but I wonder if you want to share your thoughts on, from your experience, whether you found Echidna or Medusa better at this point.
That's a good question. I liked Medusa purely because of the CLI that the UI has for it is very beautiful and very easy to look at. But after switching over to the Recon extension, I think I'm more now just stuck to Echidna. I think it feels a little bit better, and because of how the Recon extension works, I don't really have to rely on Medusa's UI, and I could get exactly what I want from that extension. So, to be also fair, I've only been using Echidna and Medusa for about the past week or two. This is my first foray into Solidity smart contract fuzzing. So.
Yeah, from my experience, having started over a year ago, at this point it's maybe a year and a half, I used to be much more of a fan of Medusa until we run into many limitations. Most of these limitations are gone now. I will consider them equivalent, and the expectation is that Medusa is going to be better in the future. However, from just working, from having experienced many, hiccups deeper in a project, so running into edge cases with Medusa, we still tend to use Echidna as the daily driver and Medusa more as the new option. And over time, we also are looking into using Almos a lot more. I believe that they already had a new release with invariant testing. So, but the main issue with formal verification tools, which we aim to support, is that their feedback loop is just less clear. And that's something we'll see in a moment. You can also control C to stop the fuzzer. And basically, what's happening now is that the fuzzer will store its corpus, meaning the sequence of calls, into a folder called Echidna. And then it will also generate a coverage report. This coverage report can be somewhat verbose, and this is one of the features that we have in our extension, is that once the report is generated, we can filter it to only show you the SRC, the files from the SRC folders, as a means to simplify it. But the coverage report in general is effectively our eyes, because thanks to that report, you can click on the right arrow, the one that pops out, that one. Basically, we're going to compress this report and show you only the SRC file, which is the most important one. And thanks to this, we can now assess the quality of our suite. The quality can be assessed by looking at the green lines, which are lines that have been hit by the fuzzer, and red lines, which are lines that have not been hit by the fuzzer. And so when we find the intersection between red and green, for example, here we see a fully red line. It simply means we never called it, probably because it's a view function. So that's not necessarily an indicator of poor coverage. It's more of an indicator of a lack of testing. Whereas if we probably go in the claiming functions, which are a little bit below, we'll eventually run into functions that are red in the middle. That's an example. And so for that, for those lines that have a bunch of green and then they suddenly become red, that means that the fuzzer wasn't able to find an input that allowed it to explore that smart contract line or that smart contract branch to the fullest.
Okay. And ideally, I would want to see, in the ideal case, the function to be entirely green.
Yeah, you will want to see them green. And then once you have achieved every function being green, that's when things get even more complicated, because you will want to think about an idea that we call logical coverage, which will be the combination of all the possible function calls, which is something that we don't have tools to actually show. We're working on this at Recon to be able to display this type of logical coverage. But for sure, as the starting point, we want to get everything to be green, meaning that we are exploring all of those transitions.
Got it. Okay. And just to rehash that, I'm looking right now at the rewards manager targets, and these were all of the functions that were called when Echidna ran. So these functions are sort of the entry points into calling the rewards manager functions and ultimately help generate the coverage report.
Exactly. This is the smart contract equivalent of having a dictionary for a fuzzer. Our fuzzer is not generating random calls. It generates randomized calls that are ABI, that are conformant to the ABI of our target functions. And these are the target functions, which are effectively we would almost call it the smart contract API, the way in which you interact with those contracts. And it's the way in which we can explore the state. And so the next feature from the extension, you can see there as code lenses, is those buttons. You have normal mode, fail mode, catch mode, and then as actor and as admin. The idea behind them is that some functions should never fail. And so catch mode allows you to instantly convert any handler to that, meaning that if you expect a function to always work, the classic function will be the increment function. When in this contract, it will be, I believe, a function to claim. You should always be able to claim, even if you have 0 rewards, it shouldn't revert. And so when you click on catch mode, that's the type of test that you're automatically activating. Whereas fail mode is more of an insider technique. Basically, when we're testing for coverage in a quick and dirty way, we will simply put a failure, assertion failure, right after the handler, and that will trigger a failure once the fuzzer finds a successful call, meaning that that's how we get quick precondition, or we simply can figure out if the fuzzer is able to reach or to generate inputs that will reach coverage for a specific function.
Right. So if I go back to the coverage port and I find some sort of function that's not there's some red there, and I just want to find a very easy way to alert me if we ever hit that function, I could go inside this contract, find the function that calls that function, and just set it to fail mode, and then the fuzzer will report an error.
Yes.
When it does complete coverage. Cool. Okay.
Yeah. So an example will be some of the more complicated functions. That's how we would want to be alerted. If I can give you a real story of me working on Euler, for example, famous security contest I did, I will put I will go in their contract, into their Vault contract. I will put a overflow check in an explicit way, as in I will type something like if numerator greater than divisor, then I will put an assertion failure because I needed that as a precondition. And so these are mostly destructive methods. You wouldn't do them when you're building your smart contract system, but whenever you want to break a smart contract system, this is the type of technique you would use to quickly get you that precondition that you may need.
Cool. That sounds like that was a fun find.
Yeah, and
So
yeah, my
go ahead.
next suggestion for you, given the need to explore state, will be that we can go in the critic to Foundry file, which is effectively the Foundry scratchpad. And what we can do is we can start to chain a few of these target functions and test them out to see why it's so hard to get to coverage. So an example could be to deposit, then add a reward, and then claim a reward with one actor. And if we're able to do this in Foundry relatively easily, then we should also expect that Echidna is going to be able to do it relatively easily itself.
Got it. Okay. So I guess the next step would be for me to create a function inside this contract that we could then call via forge test. So let me just go ahead and create this function. I guess we could just do test basic workflow. Sorry for the poor naming, but that's okay. And so now I assume I would have available these functions that I could call to initiate different actions. So I think you had mentioned we could do a deposit.
Yeah, and deposit is triggered by notify. I think something notify transfer, and it will be a notify transfer from the address 0 to an actor.
Okay. So what would be the next function I would call? I would want to deposit. I'd probably want to do, I think, having sneak peeked into the contract before, I think accrual, if anybody's familiar with rewards contracts, whenever you deposit something, you or other actions, you typically do something called accrual, which is where you just allocate the points based on the user's current balance. So I believe that already happens inside notify transfer, so we don't need to do that, obviously. The next step, I would guess, would be to we will maybe add a reward.
Yeah, we definitely want to add a reward. And this is where things get interesting because the fuzzer may have a hard time figuring out what to add, but we as humans know exactly what we want to add, right? We want to add an asset that we have. And then the last operation will be to claim the reward. But it's worth noting that because of how this contract works, you can only claim on the next epoch. So you probably would have to first warp, and then you should be able to claim the tokens from that reward.
Got it. Okay. So let me just find this. Okay. Great. Okay. So let's go ahead and update these different calls to contain information. Now, when we ran the setup contract, inside of the setup function, we created all these assets and actors. And I assume that we could also get access to this when we are running this test. So I would probably want to retrieve those actors and assets.
Yes. So if you want to retrieve the current actor and the current asset, you will simply type _get asset or _get actor. And that will give you the currently active asset and the currently active actor as chosen by the fuzzer. And since we set it up, it will be the last actor you declared and the last asset you declared.
Got it. Okay. Again, I've kind of sneak peeked a little bit into this with notify transfer. I would assume if we're doing a deposit, we could do, I believe it's setting the from address to 0.
Yeah.
Would handle a deposit.
So what I will suggest you do, just for the sake of demo, is put get actor twice. So let's try and inflate the tokens, and let's see if it failed. And I think this hopefully illustrates my point that we are using Foundry to explore the state that the fuzzer is actually exploring. And so what this line says is basically saying, get the current default actor, use the currently enabled actor, which will be the depositor as well, because the function notify transfer, if we haven't shown that explicitly, but there's every target function has a modifier called as actor or as admin that basically allows us to prank a specific address. And in this case, we're going to prank the same actor. Whereas if we wanted to separate the users from the vaults, we will probably give a different modifier to that function, because only a vault would notify a transfer. But for the sake of demo, this is fine. However, we basically are writing a Foundry test. We can then run it with the extension exposes you the function, the button run test, which allows you to quickly run it with a good verbose modality. And we would expect this to fail because you cannot transfer to yourself. And so this gives us an assurance that we could also test explicitly with the fuzzer, but in reality, we don't need to, that we will never be able to have the same input as the from and the to, and be able to call that function successfully.
Got it. Okay. So since this test fails, obviously we would want to fix this to where it actually passes, because we're just trying to run through this basic workflow and make sure that we have a positive test here, a successful test. In this case, what could we do? Could we just say address 0 then?
Exactly. We will want a mint, which by convention transfer the token from the address 0 to the recipient. And this allows the contract to track these new points, which map out to the total balances on the vault and the total supply on the vault.
Okay. And obviously I just ran the test and it's coming back with a pass. So that's good.
Yeah, that's
next
good.
is to
Yeah, the next
is
step
to
is that.
add a reward.
Yep.
Okay, so Epoch is again, I've sneak peeked into the rewards manager before, but I believe there is a current Epoch. Now, you also mentioned earlier that we can't actually claim rewards, so we'll have to shift time. But for now, we could still just mark it as the current Epoch.
Yeah.
And I think this function is,
as far as I remember, you can only claim an epoch that has ended, and you can give rewards to epoch, the current epoch or an epoch in the future. So you can literally grab rewards manager, the current epoch or the epoch ID. And then for the vault, you will want to set it to the, in this case, it will still be the current actor because of the fact that we are using the same address for both, but that could change for different vaults. And then in terms of the token, this is where you will want to use the get asset utility function from the asset manager. And for the amount, you would want to note that any amount that is above the amount that you have, which in this case is currently 0, will cause a revert simply because of insufficient tokens. So that's another revert that we would expect. So you can type any value, and I believe you would have a revert simply due to a lack of allowance and due to a lack of balance. The fuzzer, though, is actually able to mint itself tokens and to approve them. In this case, we see a revert on the transfer from. That's because our balance is insufficient. And it's a mock token, it doesn't tell you. But basically, we could go to the targets manager. No, it's the manager targets, which shows you a couple of functions that we added, which the fuzzer can also call to approve to an address and to mint to an address. And this will allow us to have the tokens and have the allowance necessary to actually add a reward to the contract.
Okay, and so just to clarify, we are minting to the current actor.
Yeah.
Okay. So I'm just going to call, and again, since these functions I could call all these inside critic to Foundry. Excellent.
Yep.
Okay, so I'll just do current actor, and then I'll just set it to 1E18, and then I'll run the test.
Now we need to
Oh,
also
looks like-
approve, otherwise we're gonna have another revert.
Oh yeah. Approve. How is it named? Approve to
Address rewards manager.
Yeah. And then we'll run the test.
Yeah, and then we're gonna run the test to see whether the fuzzer gets it. I just without the D approve.
Awesome. This is so much nicer having these helper methods versus having to stick around, look at the Forge VM, and figure out which VM function that I keep forgetting about is going to. This is just great. I'm very happy with this addition to the framework.
Yeah, we are limited by the language. There's no generics in Foundry. If there were in Solidity, if there were generics in Solidity, we would have a manager for any possible contract, which would allow you to manage, target reward manager, possible periphery contracts. Any other contract would also be able to be managed in this way. And the fuzzer can navigate through time by itself, so we don't necessarily need a handler for that. But in the test, in the Foundry test, we would. So what I will do is I will simply vm.warp for I don't remember what the epoch duration is. It's probably 1 week. But so you would either do vm.warp block.timestamp plus maybe 2 weeks. That would be a fairly decent ballpark. The alternative would be to find the constant that is being used by the contract, which would allow you to be more specific.
I think that's at the top. I'll just use that. 604 800.
Yeah, seconds per epoch. So you can either call it or grab the inline constant. And I think you will need actually. We can see whether it creates an edge case or not, because we will be, I guess you added 1. So now we're going to be on the new epoch. And so from there, we will simply claim the reward. We already are the user, but the contract actually allows anybody to claim on behalf of other people. So we will simply grab the current epoch -1 because we went in the future.
Yeah, that's right. Yep.
And then we would claim the same inputs as the rewards that you added. So those should match the input you used above. And this will indicate to us that the fuzzer has a fairly high chance of being able to reach coverage on those areas. And obviously, we could also add a before-after test. Now, to show how you will do it with the fuzzer, what you will do is, for example, you can go on claim reward, and you can set claim reward to be a fail mode test in the reward manager targets. And by changing it to fail mode, you can run the fuzzer again, which we run it with the command on the critic tester. But basically, we would expect Echidna to hopefully break this fairly quickly, meaning that rewards addition and rewards claiming is actually done. And what you're going to see, because Echidna is awesome, is that it's actually able to shrink down the repro down to those steps that we wrote. So the inputs should be very similar to the ones you wrote with some additional randomness. There's also a world in which Echidna has a lot of issues in getting to coverage. That's something that happens, especially with more complex stuff. But we can see that we have already broken the property. You can see status test 1 out of 19. And so that means that we've already broken assertion. We probably want to search for falsified to find what it was. Or you can stop the fuzzy, which is what you're doing. And once you stop it, Echidna is going to give you the shrunken repro right there. So you can see that it will In this case, it's going to break it by cheating because it's breaking it because you have no rewards. So it's just breaking it by finding a scenario where you have 0 token as a reward and hitting the early return case instead of hitting the deeper case of actually having non-zero rewards and being able to claim them.
Now, a nice thing that I can't show off right now, just for some issue with my VS Code, is that when we do run it, when we do run fuzz Echidna through the extension, is that this will automatically create a test for us inside of Critic to Foundry. That was something I had noticed a couple days ago, and I thought that was like really brilliant, because otherwise I have to take all of this output and then use a tool that you guys provide to convert it to a actual Forge test. But
Yeah.
the Recon extension does do that. And I love that.
Yeah, unfortunately, it's not showing it. So I sent you the link in the chat. It's get-recon/tool/echidna. It's the same open source scraper package that we use both in the extension as well as in the UI. And yeah, this means that this brings back the point that the Chimera framework connects the Foundry repro with the Echidna repro, meaning that you broken a property in Echidna, you can get a trace from Echidna. We don't want to debug Echidna, it's too difficult. So we just copy the logs, we put them in the tool, and then we use Foundry, which has, debugger mode, multiple VVV mode, and decode internal. And so we're obviously going to use that to debug it. And you can see how in this case it's using a shortcut, basically, kind of cheating, but we fundamentally hit the assertion failure as we requested. And this is actually kind of a key point of invariant testing, is that when you start, you will specify a property. Let's say I was thinking that we were gonna get non-zero rewards. In this case, we got 0, but the fuzzer is typically good enough that it will find a easier way to break the property until you specify the property in the correct way. So that's just how it really works. You in this case, we had this basic assertion failure, and the fuzzer is basically saying, okay, I found this easy way to break the property. So until you re-specify the property in a better way, this is all you're going to get in terms of bugs, which in this case is is not an actual bug.
Got it. Okay. So we only have a few minutes left. I kind of want to pick your brain a little bit and see, maybe not go in depth, but what would be our next step to continue work on this?
Yeah, the next step will be
fuzzing.
That we want to acknowledge the state space exploration that the fuzzer has to do, which is insanely big. And so the way I wanted to demo this project, and the way we would actually write the first few properties, which we can go and do, by the way, we can go in the properties, and we will go in the properties file, and we will basically want to go through every token that we have created, which is only free. It's basically the tokens. And then from there, we could enforce a solvency property, meaning that we would enforce that the all the rewards that we can claim are below or are at most the amount of tokens that are in the contract, meaning that we cannot break that. And then we can also write an easier property to start with, which will be to check for the solvency of the total shares that the contract is registering versus the total supply of shares that the contract is tracking. And so to do that, we will go through every vault. In this case, it's only address this, because, or rather it's all the actors, because that's how we wrote our handler. And then we will basically sum up those balances. So this can be a bit overwhelming at the beginning, but it can also be just educational to give it a shot. So we can write it.
Sure.
I'm also cheating a bit. I'm looking at how I wrote it in the background. But basically, we could write a property. So function property underscore, we could call it property underscore solvency. We typically prefix everything with property or doomsday based on what type of property it is. But at the end of the day, we're going to run an assertion simply because by convention, we write every property as an assertion failure so that we can run Echidna in just one mode. And so the solvency will effectively require us to get the balance at epoch. So there's a function called rewards_manager.getBalance at epoch, which will be basically the balance of a user. Rewards manager.
And for solvency, we're just looking at the current epoch, correct? Or we're looking at the previous one, right?
We can look at any option, and in theory, given more time, we will do a nested loop and check at all of the epochs.
Right.
But because of inductive simplification, which is a property that we have thanks to the fuzzer, which basically means that if we can break the simplest version of the property, then we can break all versions of the property. You can actually assert it only on the current epoch. And by inductive definition, if you break it on the current epoch, you could have broken it on the previous epoch, etc., etc. And so for this reason, we can actually write it as a very simple current epoch property and still retain those security properties of checking it against every enumerable epoch that the fuzzer can reach, which should be about 2 years with the default configuration.
Okay. So in terms of just real quick, Vault, I know you had mentioned so this is kind of one of the things that I find interesting as you dig deeper into the contract rewards manager. We have different vaults, and so far with all the fuzz testing, we've just allowed the fuzzer to pass in any address that it wants for the vault. Do we need to restrict that vault in this case to maybe just using the admin address, which is the current address that's testing the rewards manager contract?
Yeah, this is a important decision, but effectively, if we were to clamp inputs, which can help us simplify the tester and make it faster, then we would reduce the vault values to only ourselves or every actor. And so what we would want to do this properly will be to go in the reward manager targets and change the handler notify transfer to be only admin or use admin. So instead of as actor, it will be as admin. There's the modifier on the right. You can also use the button. And so this means that only one address can be the admin and only that address can be the vault. And so because of that, now we can go in the properties.sol and we will simply clamp the target, the value for vault to being the admin, which will be this.
Okay. And finally accepts a user, and I assume we're just going to pull the get actor because that's going to retrieve the current actor that is being used in the test.
Yeah, so we will, because we want to check the total supply versus the balance of the sum of all users, we will want to do a for loop where we iterate over all of the actors. So we will typically write something like, I mean, you can also write it in line because it's only 3 actors, but the way we will typically do it will be a for loop on all actors, where you basically will declare a variable called address square bracket memory actors equals to get actors, and you will iterate over that. You can also call get actor square bracket I every time, so that also works. You're just calling you're just reading storage a couple of times. It's not a big deal because it's a very simple test. And then we would have an accumulator for the sum of balances, and we will do some sort of a sum of balances plus equal to the balance at epoch that we got.
And get balance at epoch only returns we only care about the first variable that's returned.
Yeah, we only care about the
2.
balance. Whereas the second variable is a should accrue, meaning that it tells you whether the storage value is actually updated or whether we are reading a virtual storage value, virtually accrued value.
Okay. And if you guys watching and is not, it feels like we're going very fast here. It's also like, Alex wrote rewards manager, and I've looked at it a little bit. So, in typical, like if you're actually fuzzing a contract, ideally you should really be familiar with the contract and understand what's going on. And you'll learn that as you write the fuzz test. So don't be too disheartened if you're seeing this going very fast and you're wondering what's all this stuff. This is based on previous knowledge of the target contract that we're working through. So, and I still may make some mistakes. Hopefully, Alex can correct me if I do something wrong here. Okay, so we have this get total supply epoch. I want to make sure that's saved.
Yep. We would also get only the first parameter for the total supply. And then from there, the biggest question, because of not clamping, is whether we could issue tokens to addresses that go and are not actors. And I believe the answer is true. So we can either ship the EQ and use EQ, meaning that we expect the sum to match exactly the total supply, and we expect this property to fail because the fuzzer can try more addresses, or we could use a GTE check, which means that it's greater than equal, meaning that we expect the total supply to never be below the sum of balances of all users. And because of the fact that the fuzzer is again can simplify its own broken properties, the GTE property is actually equivalent to the EQ property. So you can actually use GTE total supply, comma, space, total balance. And as long as the total supply is above the total balance, it means that the fuzzer was never able to steal tokens for those free actors, meaning that it was unable to do it.
Okay.
So GT should break, though. It should be GTE, meaning greater than and equal.
Sorry, GTE. And so just to clarify, when we run the fuzz test, this property will run at the end of each fuzz test. So if this if this breaks, we'll see it when we run the Echidna.
Yeah, the difference with Echidna is that if you run it in property mode, you would actually be able to check the properties each time. But because we're running in assertion mode, we have a statistical likelihood that the handler is called. Because we're calling so few functions so frequently, it's technically equivalent. But technically, this is a assertion that can be checked randomly. So it may be skipped a few times, but because of how the fuzzer works, you have the statistical likelihood that if you can break the property, you will actually have a repro is super high. So it actually doesn't matter.
Okay.
It's just a long, complex way to say that, if you run it, it will tell you.
Yeah. So obviously I should have ran Forge build first because I have a lot of errors that I did not know about.
We just need to declare I as a UN256.
Yeah.
And yeah, you would always use Forge build first, and then you would go and use Echidna only when the build is successful. And in the future, we're going to find a way to cache the Echidna so it doesn't even need to rebuild. It only uses Foundry to do it.
Nice. So it's running. Do we have any questions in chat while we're waiting for this to run? I assume not. So it looks like just looking at the logs that it caught one of the tests.
Yeah, I think it's because we still have the failure mode for the claim reward. You can search for the keyword falsified to see the broken property in the logs. Yeah, so this is claim reward being broken after 1 week by calling on address 0, just trying to claim a bogus claim. So yeah, we will want to remove that canary from the target functions. But yeah, we still haven't broken that property, which is, it's almost worse when you don't break the property, because the fuzzer doesn't give you a guarantee that you can't break it. It just means that it wasn't able to break it so far.
So in this case, I'd probably just run it again, maybe with running more tests.
Yeah, we will run it for a while, and the most awesome things about, the downside of this tool is that obviously you need to run it for a while before it's meaningful. The upside of running it for a while is that all combinations that are tried are stored in the corpus, meaning that once you change the test, they will actually be rerun instantly. And so this is a subtle criticism of certain benchmarks that say that Echidna is super slow, which it is. It's extremely slow. But when you use it professionally, the fact that it's slow doesn't matter because you still have to spend a week coding anyway. So you just run the fuzzer in parallel, and then the fuzzer learns the combinations for you. So that's kind of how it is. Hopefully, in the future, we'll have fuzzers that can break properties much faster without needing to spend so much time.
Okay. So I'm not sure when this will actually find the bug. I assume it's going to be a while. I guess we could maybe. I hate to because I would love for us to see the broken property.
Well, if you want to break the
but-
property, you would want to change it to EQ. So if you change it to EQ, it should break fairly quickly because it's gonna give a balance to to an address that doesn't belong to any actor, and so it should break it relatively quickly. If you go in properties and you change the GT to an EQ.
Okay. We'll run it again and just see what happens. Oh, I seem to also have. I think I set this to. Let me just go ahead and set this back to normal mode.
Yep.
So if somebody who has never fuzzed before, what would be the I could give advice on this. You've worked on this a lot longer than I have. What would be the first contract that somebody who wants to try out Recon test?
Yeah, our first training contract is typically Morpho. I think Morpho is difficult enough that you can learn something, but it's also easy enough to set up that you can learn how everything works and be done. Then a more nuanced advice for beginners is to actually fuzz just a simple library. So find the simplest stateless library that you want and start fuzzing that. You can fuzz it with Foundry to get started, and then eventually you run into limitations with the tool, and you'll probably want to use Echidna and Medusa as well. And that's how I will suggest the starting. What we do here is more fuzzing complex systems. So I think once you go from the basic example of a library to a smart contract system, you'll run into all the issues we run into, and you start to see why we separate the contracts, we have the corpus checks, we have all the coverage shrinking. And so that I think it's going to be very natural, but the starting point should really be just a simple library. And once you fuzz that, you're gonna be in a good spot. So we see the broken property, and as you can see, Echidna is incredible at shrinking its own broken properties. It breaks it in 3 calls, and that's all it takes to break the property.
Excellent. And just running it through Recon's Echidna log parser, I was able to pull the. Let me get this up. Sorry, I was able to. Having a hard time grabbing this this terminal border. We're able to generate a forge test that would fail or should fail. Let's see. We could run the test.
And we can see that we're doing a transfer from the address 0 to dead beef, which is an address that we don't recognize as an actor, and that we mint 1 token, and that allows us to break the property. So this is the biggest issue with fuzzing, is that sometimes you're better off clamping, sometimes you're better off taking trade-offs in a more deliberate way. However, as I said, you could simply write the property to be a GTE, and if we can break the property as a GTE, then we actually have a critical bug in the system. Whereas until we can break it with a GTE, then we wouldn't look at this as a cause for concern, but rather this is simply that we specified the property to be overly strict, given the target functions that we wrote.
Gotcha. Okay. Excellent. I mean, I'll keep running this in the background. I think this is a really great talk, Alex. This is a lot of insight that I think if anybody's interested in fuzzing, should take a very serious, hard look at. Especially if you're doing like audit contests. I don't do them anymore, but if I did, I probably would start using Recon almost solely in audit contests. I think it's a very valuable tool that you're leveraging that not many people use, and is going to produce some very interesting results that I think is difficult for humans to identify in a short period of time.
If I can mention a couple of bugs we're gonna go public soon with. I'm gonna
Absolutely.
do a talk at IF Belgrade in a couple of weeks about how a 1 second rounding error, we actually were able to escalate it to minting about $100 million of liquidity votes on the liquidity gov
Wow.
contract while we were developing the contract for liquidity. And another bug that we never published, but we're gonna go public soon, is a explanation of how we were able to inflate balancer V2 LP token prices by using the fuzzer. We literally just forked a balancer V2 pool. We gave the fuzzer the ability to alter the fair reserves, and then we priced it, and that allowed us to create a critical bug for Baraboro, which obviously was mitigated before they launched. But that's the
Yeah.
type of bugs that we find very frequently, is that escalation from the low severity truncation to the critical bug. That's where the fuzzer really shines, and that's the type of bugs that we have plenty of stories of.
Oh, awesome. I'm glad to hear that. And I just want to say thank you for pursuing uh, and really raising the bar on Solidity fuzzing, because I think I really like fuzzing in general, and I think it's a very, very nice tool to have as part of your arsenal for auditing smart contracts.
Yeah, I really believe in that as a technique. It's something that gives me the ability to give it a second look. Like I can poke the system from a different perspective and hopefully make sure I don't miss bugs from manual review. That's how I would use it. And yeah, in the future, as we make the tooling faster and easier to use, I would expect more people to use it for contest. Whereas as of today, there's still a big learning curve. So for people like me that did use the technique, we're getting the results. But I think we're still a few months away from another 10x or 100x improvement that will make this technology truly accessible to all developers.
Yeah. It's understandable. Awesome. Great. This has been a really fun talk. Alex, where can we find you, or can we download Recon Extension and check out all the material that you guys produce?
I would say the best best single link will be the book. We have book.getrecon.xyz, and you can get all of the resources that we spoke about. Whereas if you want to follow us, you can follow us at on x.com/getreconxyz. And I'm also gonna drop my Twitter, which is unspellable, so I'll just drop it here in the chat.
I'll forward all these links to a general channel after the call. So yeah.
Great. Awesome. Well, this is Alex again. Thank you so much. Jason, obviously I'm Jason, Ellen. We want to thank you guys for watching. You guys could always stay in line on Remedy Discord. We're always trying to host events and a lot of new interesting stuff that we're trying to cover. and the entire smart contract landscape and Web3 in general. So thanks for watching, guys. We will also be having publishing this on YouTube, so you could watch back at a later time. And we'll probably post when we'll be publishing it, I'm sure, soon. So thanks again, guys. Hope you guys have a great rest of the day. And please, please, please check out Recon Extension. It is I really like the tool. It's making me now switch to Solidity fuzzing, or having a very serious thought about it. So
awesome. Thank you for having me.
Yeah.
Have an awesome rest of your day. See you in the arena.
Thanks, guys. Have a good one.
Thank you, guys.